All right, what is going on, everybody? It's Kistner again, and today we are looking at the last section of Topic 3 that we are going to study this year about polynomials, really. It's 3.6 in your book. Student Companion will be on page 84, and it's called Theorems about Roots of Polynomial Functions, and there are some pretty important theorems in this, so let's get started. Now, here's the rational root theorem. And you can read it. Let p of x be a polynomial with integer coefficients. So all the a's here are coefficients. If polynomial equation p of x equals 0, has any rational roots, remember rational are numbers that can be written as fractions. If they have that, then each rational root is of the form p over q, where p is a factor of the constant term, and q is a factor of the leading coefficient. Now that's really wordy, so let me show you what it means with an example. Okay, so example 1 here should be on page 84. It's what you should be looking at. It says this: list all possible rational solutions. So list all possible rational zeros, roots, x-intercepts, whatever. Basically every number that is possibly to make this true, to make it equal to 0 like it's written. So what I look for is it is the factors of the constant over factors of the leading coefficient. I'm just going to put coef. Okay, so in this problem, here is your constant, and my pen's not synced again, and here is your leading coefficient. So I want factors of 8 over factors of 4. So in this case, I think of the factors of 8, plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Those are the factors of 8. Those are the only numbers that multiply to get 8. And the factors of 4 are plus or minus 1, plus or minus 2, and plus or minus 4. So I have to list all possible combinations of this fraction. So I always start with 1 over, I just go 1 over 1, 1 over 2, 1 over 4. Okay? So 1 over 1 gives me plus or minus 1 over 1, or just 1. 1 over 2 is plus or minus 1 over 2. And then plus or minus 1 over 4. Okay, so now the next one is 2 over 1. I'm going right here if you follow my mouse. So it'll be plus or minus, there should be a minus sign under all these, I don't know why I didn't put it, 2 over 1. Plus or minus 2 over 2 is 1 over 1, so I'm not going to list it again. 2 over 4 is 1/2, so I'm not going to list it again. And I'm done. That's pretty nice. Those were already covered. 2 over 1 was the only new one, because 2 over 2 is 1, 2 over 4 is 1/2. That's good. So now I go to 4 over 1. I'm just moving down the rows each time. 4 over 1, plus or minus 4 over 1. 4 over 2 is 2, so I don't have to list it again. 4 over 4 is 1, so I don't have to list it again. And then 8 over 1, plus or minus that. And then 8 over 2 is 4, so I've already got that listed. And 8 over 4 is 2, so I already have that listed. So here are all possible zeros. So if we wanted to write this a little more simplified, it would be plus or minus 1, plus or minus 1/2, plus or minus 1/4, plus or minus 2, plus or minus 4, and plus or minus 8. Now what this means is one of these numbers, I have 1, 2, 3, 4, 5, 6, so I have 12 numbers here because I have the plus or minus side of them. When I plug them into this function up here, it'll give me 0. So if I plug 1 in, it might give me 0. I don't know. If I plug in negative 1/2, it might give me 0. I don't know. But it didn't ask me to figure that out yet. What it asked me to do was to list all possible ones. We'll do this again tomorrow or the next day in class when we work part B together. So a jewelry box measures, go on example 2. A jewelry box measures 2x plus 1 inches long, 2x minus 6 inches wide, and x inches tall. The volume of the box is given by 4x cubed minus 10x squared minus 6x. What is the height of the box in inches if its volume is 28 inches cubed? Okay. So the volume is 28 inches cubed. So V of x, that's the volume. So I'm going to put 28 equals, that's volume, equals. And it tells me it should equal this, 4x cubed minus 10x squared minus 6x. Now, if I I want to know the height. Okay, here's the height. It's x. So basically, I'm asking what x can make this thing equal 28. Another way to look at it is we're not used to having a number over here. So I'm going to subtract the 28 to get rid of it and put it over here on the end. So what I really have is 0 equals 4x cubed minus 10x squared minus 6x minus 28. Okay? And I want to know the 0. So what I need to do is to list all possible rational roots. So it'll be the factors of 28 over the factors of 4. So the factors of 28 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 7, plus or minus 14, and plus or minus 28. The factors of 4 we've already done, plus or minus 1, plus or minus 2, and plus or minus 4. So now, what I would do is plug this into my calculator and figure out which one of them does actually give me a 0. Okay? And when you do this, it's going to take you a while to test. But what you would do is you would type in 1 over 1. Does it give you a 0? No. 1 over 2. Does it give you a 0? No. 2 over 2. Does it give you a 0? No. So forth. I'm going to go ahead and tell you what this is. This answer is going to be 7/2. That's one of them that does it. So what we want to do here, what you need to understand is if you plug 7/2 into here, it gives you 0. It's a true statement. The only way you would have known that is by plugging all of these into your calculator. It will do that together in class next time I see you. So here's the key theorem. It's called the fundamental theorem of algebra. Like, it's very important. It says, if p of x is a polynomial of degree greater than 1, meaning it is not linear, or it's linear, it's not a constant, linear or greater, linear, quadratic, cubic, whatever, then p of x equals 0. So when you set it equal to 0, it has exactly n solutions in the set of complex numbers. We have been saying this forever. If I tell you that you have a 4th degree polynomial, that means you can have 4 solutions. If you have a 5th degree polynomial, you have 5 solutions. That's all this says. If p of x has any factor of multiplicity, count the solution associated with that factor n times. We studied this last class. For example, the equation x minus 3 to the 4th equals 0 has 4 solutions, and each of them is 3. Let's use this a little bit. That makes more sense if we use it a little bit. So what are all the complex roots of this equation? Okay, so I need to factor this. Okay? So what I'm going to do to factor this is type this into my calculator. Okay? Let me clear everything out. Turn my plot off. And I say y equals Sorry, no, that's wrong. That's wrong. Sorry. It's x cubed. I was looking at the wrong example. X cubed minus 2x squared plus 5x minus 10. And I'm an idiot. X cubed minus 2x squared plus 5x minus 10. Plus 5x minus 10. All right. Now, I'm going to graph this by hitting zoom 6. And hopefully I will see a root. Right there. So I want to know where this occurs. I want to know where that right there occurs. So I can use my second trace function, second calc, and find the 0. And scroll till I see it. And say it's to the left there, to the right there, and hit enter. And it says it's at x equals 2. So I know 1, 0 is at 2. What that tells me is I have a factor of x minus 2. Okay? That's a solution. So that gives me 2 is a solution. I need to factor all this. X minus 2 is a factor. So what we're going to do is synthetically divide by 2 here. I know that's one of them, and synthetic division should get the rest of them out for me. I need 3 roots. That's what the fundamental theorem of algebra says. Find 3 roots. So I'm going to put my coefficients down. 1, -2, 5, and -10. And I can use synthetic division because it is a linear factor. Drop the 1, 2, add, give 0, multiply, get a 0, 5, and 10, not -10. Whoops, do all that again. And I add, I get 0. So I have a remainder of 0, which is good. So what this means is, that's what I wanted, by the way. When I plugged in a 2, I should have gotten 0, and that's what I got. This becomes that I have factored this big, long polynomial into x minus 2, and that's as x squared plus 5, and the whole thing's still equal to 0. That's what I'm trying to get, equal to 0. So now I know that this will give me 2, and this gives me x squared plus 5 equals 0. And when I solve this, x squared equals -5, square root both sides, x equals plus or minus I square root of 5. I have three zeros. I have this 1 0, and I have 2 zeros here, and I have all complex roots of the equation. I'll do another one of those in class as well. So I'm going to leave this word problem here as well. So I will see you guys next time in class. Make sure you go back and rewatch this, and I'm going to leave this screen on the video, and I want you to probably screenshot this because I'm going to reference these a lot in class, so I want you to kind of have them. But other than that, screenshot this, save this somehow, and I will see you guys next time. This is Kistner out.